Time for task number 2. Okay, so this one's about a flying squirrel. A flying squirrel jumped from a tree 11 feet in the air at an initial velocity of 9 feet per second. The equation h equals negative 2t squared plus 9t plus 11 models his jump where h is the height in feet and t is the time in seconds. Okay, so I've got 3 different parts, A, B, and C, that we're going to go through on this one. You may at this point have noticed, like, okay, they use the number 11 and they use the number 9 in here, and then 11 and 9 are also in the equations as well. Good, I'm glad you picked up on that. Remember, if your quadratic is in standard form, C is your y-intercept, right? Well, it says that he jumped from a tree that was 11 feet in the air. Okay, so 11 feet in the air. Well, folks, that's his y-intercept. That's his initial height. Okay, so again, I sketched a little coordinate plane here for us where x is time in seconds and y is height in feet. So I'm going to pick a point on the y-axis and I'm going to say maybe this point right here is 11 feet off the ground. So here's 0, here's 11 feet off the ground, right? So the squirrel is in this tree. He's a flying squirrel, so he jumps, and then he reaches a maximum height somewhere right in here, right? And then he's gonna hit the ground at some point as well. So again, 3 points that we're really interested in, right? This one right here, which is called the y-intercept, right? His initial height, okay? Right here is our max point, which is called our vertex. And our vertex has an x and a y. We know that the x's stand for time, and we know that the y's stand for height, okay? At a certain time, he's going to reach a max height. And then he's also going to come back down to the ground, right? Hopefully it's a soft landing. Okay, so this would be a 0 of the function, okay? One of our zeros or one of our x-intercepts. All right, so 11 was the y-intercept. That 9, this middle term right here, is always something called our initial velocity, okay? It's like a force at which we throw something or we push something or we jump from something, okay? So that's our initial velocity. And so it says he jumped with an initial velocity of 9 feet per second. This first term right here, this is just kind of going on a tangent a little bit. This is our, this is where gravity is acting on our quadratic, okay? So you'll get into more details with that in Algebra 2, but for right now, I just kind of wanted to point out a couple of things here with the initial velocity and your y-intercept right there. All right, let's get started on part A. What was the squirrel's maximum height? What was the squirrel's maximum height? That's a vertex question. It's a vertex question, right? We know that in our vertex, the x's are the number of seconds, the y's are the height, okay? So what was the squirrel's maximum height? We're looking for the y value of the vertex. All right, so let's get started. Part A, if I want the y value of the vertex, I first have to find the x value of the vertex. And to do that, I need my vertex formula, negative b over 2a. So negative 9, because b is 9, over 2 times whatever a is, which happens to be negative 2. So negative 9 divided by negative 4, right? Negative 9 divided by negative 4. Let me adjust my lighting a little bit in here because it's kind of hard to see. There we go. Negative divided by a negative is a positive, right? So 9 divided by 4, that's going to give us what? 2.25? 2.25? I should have had my calculator ready to go. Let's see. So 9 divided by 4, 2.25. Okay, so 2.25. And remember, this is an x value, so this would be seconds. At 2.25 seconds is when that squirrel is going to reach its maximum height. But we don't want to know when, we want to know what's the height, right? So that's when we have to do h of 2.25. H of 2.25. So I'm going to plug in 2.25 as my time, and I'm going to solve for the maximum height of the quadratic, okay? So remember, you can use your calculator on your phone. Let me clear this out here. So the first thing I'm going to do is 2.25 squared. So 2.25 squared gives me 5.0625. Then I need to multiply that by -2. That gives me -10.125. Next, I'm going to multiply 9 times 2.25. 9 times 2.25. Let me try that again. 9 times 2.25. So that gives us 20.25, and then I'm going to add 11. Okay, all right, let me do some adding and subtracting here. So 10.125, that's got to be negative, plus 20.25 plus 11. Okay, so we have a maximum height of 21.125 feet. Let's make this make sense. So here we go. So we have h of 2.25 equals 21.125 feet. Y'all, I'm kind of impressed with this squirrel, all right? So he jumps from a height of 11 feet off the ground. First off, he's fearless, okay? Secondly, he gets 21.125 feet off the ground as a max height. Please don't try this at home, okay? But I mean, I think that's pretty impressive for a squirrel. So his vertex is at 2.25 seconds. That squirrel is 21.125 feet off the ground. We're talking about this point right here, his max height. So I know that this time right here is 2.25 seconds. I know that his max height right over here, 21.125 feet. Impressive squirrel, okay? So the answer to part A would be that 21.125 feet, because the question was asking, what's the squirrel's maximum height? There you go, 21.125 feet. Let's look at part B. How many seconds after he jumped was the squirrel at his highest point? How many seconds after he jumped was the squirrel at his highest point? Again, they're asking about highest point, y'all. That's the vertex. Vertex, the x's are seconds, the y's are height. What are they wanting to know? They're wanting to know the x value of the vertex. Well, hang on a second. We already did that in part A. Ooh, a twofer. I love a twofer. Okay, so part B, I want to know at how many seconds was that squirrel at his maximum height? Boom, right there. You already did it. You already did it, and you did it in this part right here, where it was -b over 2a. You already found the time at which that squirrel was at its maximum height, okay? At 2.25 seconds. That's when the squirrel was at its maximum height, okay? All right, well, let's go to part C. When did the squirrel reach the ground? When did the squirrel reach the ground? Remember, he's on that trajectory right here. He's jumping, he goes up, and then gravity is pulling him to the ground. So when is he at the ground? We need to find the zero of the function, right? 4 different ways that you can do that. You can factor, you can use square root method, you can complete the square, or you can use quadratic formula, right? Okay, so I have a feeling that, I don't know, maybe we won't get a whole number on this one. I'm going to use the quadratic formula. Y'all, I'm going to go to the quadratic formula most times, okay? So -b plus or minus the square root of b squared minus 4ac divided by 2a. We need a, b, and c. So we're going to look at the original function and we're going to write down a, b, and c. A is the coefficient of t squared, so -2. B is the coefficient of t, so 9. And c is our constant, 11. I'm going to start plugging some numbers in. -9 plus or minus the square root of 9 squared minus 4 times -2 times 11 divided by 2 times -2. All right, use that calculator. Y'all can use a calculator to help you on this part. 9 squared is 81. -4 times -2 is +8, and 8 times 11 is 88. So plus 88, and then divided by 2 times -2 is -4. Okay, then we're going to add together 81 and 88. 81 and 88, and that's going to give us 169. We like 169 because it's a perfect square. It is a perfect square. If you're unsure about that, you do have, if you're using your phone like this as a calculator, I've got 169 right there in my calculator already. Find the button that says square root, right? For me, it's this one right here, if y'all can see what I'm pointing to. It's got a little 2 as the index. I know it's hard to see. So a little 2 is the index, and then a square root. So if I hit that, there we go. I took the square root and I got a nice whole number, 13, because 13 times 13 is 169. So that's going to give me -9 plus or minus 13 divided by -4. I'm going to split this into 2 answers. I'm going to have -9 plus 13 divided by -4, and I'm going to have -9 minus 13 divided by -4. -9 plus 13 is 4. So 4 divided by -4, which would give me a time of -1 second. We'll come back and talk about that one. -9 minus 13 is going to give me, what is that, -22? -22. And then divided by -4. So -22 divided by -4 is going to give me +5.5. +5.5. So that's 5.5 seconds. 5.5 seconds. Okay. Let me read the question again. When did the squirrel reach the ground? When did the squirrel reach the ground? Did the squirrel reach the ground 1.5 seconds before he jumped? That's what this means, this -1 second. If I look at it on the graph, it would be some time frame over here in the negative side. Does that even make sense? Did he reach the ground before he even jumped off the tree? No. Okay, so again, this is the one that we have to ignore. All right, we're going to focus on this one right here, the 5.5 seconds. So I know that at 2.25 seconds, he's at his max height. And then look at that, at another 2.25 seconds later, he's hitting the ground. So at 5.5 seconds is when that squirrel hits the ground. 5.5 seconds to be airborne. That's pretty impressive. I don't think any people could pull that off. And again, don't try this at home, especially right now when our ERs are being overrun. Okay, just a little PSA for you. Don't try this at home. You should be sitting behind your computer working on these task cards all day. Okay, I hope this helped you out. Again, we're skipping number 3. Your job now is to look at task cards 4 through 9, and you're going to pick 4 of those to work. You're going to work them out on your loose leaf paper, take pictures of them or scan them once you're finished, and I want you to email those problems to me. So you have 6 of them to choose from. You only need to do 4, okay? If you have questions, let me know, folks. I'm available through email. I can Zoom with you if we need to, if you need to get some extra help. Tuesday at 12 o'clock, I will also be on Zoom to answer questions. See you then.